I'll stop the video. Okay, Ramanand, how is it now?
Yes, sir. Clear.
Okay, I will not put the video as well. Uh, I hope everybody is fine and safe at their respective homes. Yesterday, I have sent few things. One of the things that I first sent was the slides and the notes with regards to the discussion that we had in yesterday's class. That was the transmission media. Another thing that Ramanand uploaded is the riverbed modeler. We can take this on Thursday or Friday, depending upon if your installation is done. We'll have our lab number 2. Everybody has to install it. We'll try to do it parallelly. I would demonstrate here through the share. I can show, I can, share my desktop and then you can follow stepwise. So I would suggest that you install it. There are some issues like some people have posted with regards to Linux based system. I do not see any free version of Linux there. We need an academic version. The full version we have to pay for it. As of now, we just require an academic version to try our labs. The third thing is that I have sent you a sheet which mentions OSI model. Let me try video. This sheet is basically a whole gist of the OSI model. If you look into this side wherein we have the layers, then we have the names, the mnemonics, how to remember it, then components. And then we have basic small description of what it does. If I go to number 1, this was 2 pictures which I had uploaded there. If I go to number 1, that is the physical layer, mnemonics is processing, encapsulation is bits. It's what we were talking about, raw bits. Then we have devices or components. The examples that we took yesterday: repeater, hub, transceiver, transmitter, receiver, and so on. These are the devices that come under it. Then we have keyword and description. A summary of what it is supposed to do: binary transmitting of signals, encoding, layout of pins, voltages, cable specification, modulation, and so on. Then we move to the second layer, which says data link layer. Mnemonics is data. That is for you to remember the 7 layers, the order of it. All people seem to need data processing. So the term that it uses for encapsulation units, it says frames. So if I say that I have a frame, so you should imagine that I am talking about layer 2. If I say a packet has been sent from A to B, you should imagine that I'm talking about network layer. All of you parallelly open this picture that was sent yesterday. If I talk about that, we have a network segment moving from A to B. You should imagine I am talking something about transport layer. The rest of it is data there. Overall, generally, I might speak that a packet is sent from one end to another end. But this is the encapsulation unit. This is what actually it's supposed to be. Bits, physical layer, frames, data link layer, packets, network layer, segments, transport layer. And then comes the devices or components. We have in the physical layer, as mentioned just now, then we have data link layer, bridge, switch, NIC, that is the network interface card, and its functions is given there. And the third layer is the router, the network layer. Means that if I talk about a device like a router, you should by itself imagine that I am talking about layer, that is network layer or layer 3. If I say network layer device, by default, you should imagine I'm talking about a router. Then you can see transport doesn't have mentioned device there, session doesn't have presentation and application. It's written PC, right? A desktop PC, a laptop. So all these starting from transport up to the application layer, this is supposed to be within end systems. And we will come to this when we'll discuss end-to-end layers beyond the network layer, that's transport layer onwards. And then the next part of this picture is comparison with TCP IP protocol, right? Here we have 7 layers, TCP IP we have 4 layers. This is important here to understand the picture, the tabular form. You can see the table here in physical and data link layer. They are combined together as the network layer. You can see the physical layer as well as the data link layer have been combined to form TCP IP's one layer, and they call it as network access layer. Network layer on the left side of OSI is internet layer, similar, working and so on. Transport layer is transport layer has here as well. And then session, presentation and application of OSI layer has been combined into single layer, which is the application layer. Why TCP IP says that session or presentation are optional layers? They are sometimes used, sometimes not used. So roughly we can just combine and form a single layer for this. But since OSI gives a very good distinction between all these layers, it is better for us that we use OSI to understand these. And then the next picture, I have the other side of the page, which says examples, right? I'll go to the first layer that we discussed, that was the physical layer. It mentions first one as OSI protocols, X.25 and so on. This is the example of OSI protocols that we have. Then there is TCP IP, what is the one parallel to it. Then we have signaling systems, Apple Talk. This is another, network model. Then IPX, then SNA, then UMTX. But last one that we need here is the examples that we have. The example is, for example, RJ45. That's what we discussed yesterday as connector. Full duplex, the communication medium in which both you can send and receive at the same time, which we discussed yesterday, is there. NBST, SONET, SDH, DSL, and so on. So we'll be referring to it more often to understand which devices were and so. So for today's lecture, yesterday we discussed about the transmission medium, we discussed media, and we discussed the uh, unguided media. The topologies, which was your assignment, so that was taken care as well. Then we discussed some transmission impairment also. Another thing that comes under, you know, uh, device of physical layer is modem. Nowadays, we do not see those typical modems that we used to have uh, for data communication in homes. They are all now combined together within the devices that we are using. Modem stands for modulator and demodulator. What it does basically, it's a device that would accept a serial stream of bit as input and produce a modulated carrier as output, or vice versa if you're sending it across. And it used to be in between the telephone line and the computer. Now moving on to the next layer, that is what we know as the data link layer. I'll start with the screen, whiteboard. Is layer 2, which is also known as data link layer or simply DLL. Ramanand, you can see? Yeah, it's written there, layer 2 data link layer. There is a lag. Still, Ramanand still not there. Huh? It's taking a lot of time today. Arifa is on no. What do you see on whiteboard, Arifa? Layer 2. Okay, fine, fine. So it's taking a bit of time, but it's working. So fundamentally, we are now moving from the layer 1, we are moving to layer 2. What does layer 2 function as? Layer 2 from the sending system takes the data from the network layer, does some work on it, adds its own header, which is the data link layer header, puts the information about what working it has done within that header, passes on to the physical layer. Then the physical layer does its work and sends these, you know, as bits one by one over the link. And now we are moving to the data link layers, working, what it does, what services it provides. So this is what we call as link layer, and link layer has two types of channels. So link layer has two types of channels. The first channel that we have is broadcast channel. And the second one that we have is point to point channels. What is a broadcast channel? Commonly, the channels that you use in your lab, a LAN or a wireless LAN like Wi-Fi, satellite networks, hybrid fiber cable networks, they are all broadcast channels. We discussed in the previous class what is broadcasting, unicasting, and so on. In broadcasting, it was one to all, which also means that in a LAN, if there are 30 computers in lab on one side of a department, if all of these are connected to the same switch and you're sending data from one node to another node within these 30, this means that all the 29 nodes would receive this signal, what you are sending, because this is what we have as a broadcast channel. However, when all of these receive, only the one which is supposed to accept it and take it takes it to the next layer for processing and so on. We'll see how this is done when we match the MAC addresses and then IP addresses. This type of channel is what we know as broadcast channel, in which many hosts are connected to a same communication medium or a same communication channel. And why is it important for us to discuss broadcast channel or broadcasting? Because we would need some protocols by which we would have to coordinate between who can send and who cannot send. All right. Then the second one that we have is the point-to-point link. Well, it's like, broadcast channel is like, this time we are around, how many are there in the class? We are around 32 participants. Ramanan, do the attendance. Within these 32 participants, is everybody has to talk. If I say, okay, talk, everybody starts to talk. Do you think I would be able to understand what you are saying? No. Why? Let's say if I say all first three, Abhay, Abhishek, Kumar and Abhishek Rathore, start speaking, all three of you. Start speaking, all three of you, yes. No, I'm not able to listen to anything. No, guys, nothing. All right, everybody, whosoever can, just speak for a minute. Take off your microphone and speak.
Hello.
Yes,
Hello.
other, yes. Together.
Yeah, hello. I
Hello.
was Hello.
Yes, I got the example. So what happened here is so many spoke together, I could not understand what it meant. And likewise in a broadcast channel, when everybody starts to speak, okay, if you do not coordinate between one and another first, then now I'll say first Abhi speak, then Abhishek Kumar, then Abhishek Rathore, then Ankur, then Ankur Goswami. So in an order, if I give chance one by one, like round robin, there wouldn't be any confusion there. There wouldn't be any confusion, right? So we would need such protocols in broadcast channels which would coordinate between one and the another one. These are known as media access control protocols or simply MAC protocols. So they would coordinate between who sends first and who sends next. I will try to upload the PPT as well in a little while so that we can continue with PPT also. Now coming to the next point of the data link is what we call as service model. We had a service model in which we said if we have A on this side and B on this side, within each we have, let me draw a link here, a link here connecting the two together. Okay. Now we say here, this is the service model. Let me trying to draw, I'll try to wait a bit so that you can see what is there. Okay, Raman, what do you see this time? Yeah, do you see the layers also in the picture? Okay, fine. Arifa? Okay, right. So So what we have here is on two ends a sender A and a sender B. And within this, we says A is sending data to B. I would draw a different lines to show this. One I will show in pink. This is, I say data is being sent from A to B. So Facebook Messenger A is sending data to Facebook Messenger B. Or node A is sending to node B. This is how we simply say. Then actually when we say this, we say A gives the data that I will depict with a green line to the application layer, which gives to session, presentation, then the transport, then network layer, then data link layer, and then physical layer. Physical layer responsibility here is to put it over the link. I'm drawing it as green over the link. Then the receiving end would take from physical layer to data link layer to network transport up and give it to the Facebook Messenger in B. So pink one is how you would say it, A is sending to data to B. But actually the fundamental here would be A communicates it through the protocol stack, through the wire, and then to B, the green line. Fine. And within it, green is, let me write it, actual path. This is basically actual path. We do have another one, what we call as virtual path as well, in which I would say that data link layer that is of A communicates with the data link layer which is of B. Okay. This path is known as virtual data path. Virtual data path. That is this path. In which I say the data link layer of node A communicates with the data link layer of B. Why is it virtual? Because actually it doesn't happen. Data link layer passes on to the physical layer of A, physical layer passes on to the link connects to the node B, to the physical layer, and physical layer then to the data link. And we would require the link layer protocols to move this datagram from A to B. The link layer here defines the format of how a packet should look like when it's sent from A to B. So I will write here in black that data link layer defines the format of packets, what we here know as PDUs. And what is PDU? We saw it in previous classes. It's a protocol data unit, typically known as NPDU, where N is the layer you're talking about. So if I say NPDU of data link layer, I'm talking about data link layers PDU, data link layers protocol data unit. And what do we call data link layers PDU, protocol data unit? We call it as frames. The answer is frames. So what are frames basically? Frames are units of data exchanged by link layer protocol This is frame. So I'm talking about data link layer, communicating to data link layer. I'm talking about a term that is a frame. How do we see this now? You got this data, which I will draw it in red as a packet from the higher layer, that is the network layer. Network layer calls it packet. Packet is sent to the data link layer. When it takes it, it encapsulates it. So I would have I would encapsulate it like this. Okay. So I would cover it up like you put a letter inside an envelope and send it. So I will encapsulate one network packet into one frame. And also I would have some message, some information here, which would mention what it is, like this one. So the red one is the packet that I got from the transport layer. The light blue one is the header of the frame. And then overall combined together, I encapsulate it and I call it as a frame of data link layer. Typically, one frame would be formed by one packet that is being passed by the network layer. Next, let us see the examples of the data link layer, the protocols that we come. Protocols of data link layer. Typical example is Ethernet. We'll discuss about Ethernet also. There is another one, we'll do comparison between Ethernet and token ring. There are two examples of the data link layer. 802.11 wireless LANs. Yes, WLAN is also an example of the ATM in many places is taken with an, in some countries is taken with this. PPP, point to point, is also part of this as well. Fine. To understand, this what link layer protocol does, one example that the Kuros also gives is if you plan to come from, let's say, Delhi to Srinagar, you take typically, let's say you are going home from Srinagar to Delhi. From Srinagar airport, you'll take a car. From airport, you take a plane to Jammu. From Jammu, you take a train to Delhi. Okay. So for all the three, car, plane, and train, you need three different reservations. Then it is the responsibility of car company, the airlines, and the train services to take you. There are three different segmentations that come here. First segmentation is the road one. The second segment is the plane one, and the third segment is the train service. So we have three transport segments which are managed by three different companies. All three are different transportation mechanisms, but all three provide the same service, that is taking passengers from one destination to another destination. Seeing this example, bring it into the networks. You are going from Srinagar to Delhi, so you are analogous to datagram that is being sent. Each transportation segment that we saw is a communication link, like from here to airport. I said, let it be wireless. You're first wirelessly connected. then you are connected to a wire, then you are this Cat6, then you are connected through fiber. So each one is a transportation mode. And the one who's responsible to book your 3 tickets, the one who's responsible to take you from here to there in booking is your routing protocol. So let us understand these. Let's go to simply now the services offered. I'll just clear this board. Now is the important part. We'll take about any questions about the introduction to data link layer? No question? Let me just see if we have everybody listening. Rahul, can you say something? Rahul, can you say something? Rahul is sleeping. Oh, he's fine. Okay, okay. Okay, fine, you're active. All right. I just thought to do a random check. If anyhow, let me go back. So we are now going to an important aspect of services offered by link layer. The first thing that the link layer does is known as framing. Framing. And what is framing? Just now I showed you a box. You encapsulate a network layer diagram packet. So I'll just write encapsulate each network layer datagram. That is framing within a link layer frame before transmission. This is what we have as framing. The example that I gave here, I would have a box here, this thing. Inside it, I would have a network packet. This one. Drag it. Anyhow. I know, okay, fine, that's fine, that's okay. Okay, no issue, no issue. No issue, no issue. Okay, fine. So what I was showing here is this would be our datagram. That this would be our basically frame, and within the frame we would have a data part. So I'll break this into two. One part is the data, and what is within the data? Within the data, I would have what I have received from the network layer. That is the network layer datagram here within this part. And what is within this? The header field. So two parts that I have here. One is the data field. And the second part that I have is header field. What is within the data? Whatever the network layer passed to me, I put it as a data field. Like you put a letter in the envelope, Letter is what the network layer packet was. And the envelope that you made and put on the address and so on was the information that is kept into the header field. Like I said, each layer would do its work and put the work that it has done, the information about that in the header field. And sometimes or some books might also mention that a packet has a trailer field as well. I'll draw this here. So I will have a trailer field as well. So header in the front, then the data, and at the back is trailer. However, we do not generally mention trailer. You will always hear about header field. Why? Because header and trailer, sorry, I done a mistake. It's T-R-A-I-L-E-R, trailer. Trailer fields both are referred as header field. So I'll just mention it as header field. I won't take that. So this is first function that it will make the frame. How it will make the frame, we are going to take that in a little while from now. The second one that we'll come across, the function is link access. We would require a certain protocol which we call as medium access control or MAC. MAC protocols, and these MAC protocols would specify the rules by which we can send a frame from one end to another, by which it will tell us whether I can send now or I would have to wait and so on. Just now I mentioned that we have two types of link. One is the broadcast link, one is the point-to-point link. For point-to-point link, that is between two nodes only, MAC protocols are very simple. They are almost non-existent. It's like between me and Ramanand. If we are talking, I say something, he replies back, then I say something. I don't need somebody else to coordinate who would speak first and who would speak next. Likewise in networks, when we have P2P, whenever the sender sees that the link is not being used, link is idle, it starts to send it when it's P2P. But this doesn't happen in case of broadcast medium. For broadcast medium, we would need MAC protocols to define who will first send and who will send next and so on. Whether I can send or whether I can send. This we are going to discuss as well. Then we have reliable delivery. What is a reliable delivery here? Okay. You say somebody, okay, I trust him. He's a reliable guy. Here in this context, we have reliable means guarantees to move each network layer datagram across the link layer without any error. I would write this. Guarantees to move each network layer datagram across the link without error. We will come to transport layer, then we will see what actually reliable data delivery is. But TCP is of transport layer. How reliability is achieved there. And we'll see here also how reliability is achieved by the data link layer. The link layer's reliable delivery service is typically used for those links which are error prone links. What links do we call as error prone links? I said yesterday also, error prone links are those where we have maximum possibility of having errors. That is the wireless link. After that, we have lesser error rates, 10 to the power of 5, 10 to the power of minus 6, like we have in WANs and these UTP and so on. And then we have errors of almost zero, negligible errors. That is when we talk about the OFCs or fiber. So this reliable delivery, error-free delivery guarantees can be provided by data link layer as well. And if I say that we have a protocol which takes of reliable service on which takes care of reliable service on transport layer, then why are we discussing this reliable delivery at data link layer? An interesting question here. I repeat the question. Okay. If I have TCP as transport layer reliable delivery service in which we have acknowledgements, retransmissions, and so on, why do we require reliable delivery at the data link layer as well? An answer for this is that we are targeting to have, or we have a goal of correcting an error locally on the link itself where it has occurred. As compared to TCP, if we have TCP, you see the page that I have given you, the transport layer protocol are available from the sender to the destination. In between, there is a router, there is a switch. They are not aware of these. So if we are talking about reliable delivery at transport layer, it has to be end to end from source to destination. If a packet has a problem, the destination could not get that packet, source has to take care about this. And what happens in that case if there are 10 intermediate hops? So everybody would be involved in sending it. Whereas, let me draw a picture to make you understand this. This is a sender, this is a destination. In between there are few switches, there are few routers as well. There are, so now if I connect them, okay, is this figure visible? Amrand? Not yet. Mary now? No, a scroll is done. I'm in new. I have cleared all. Oh, you mean, okay, okay. I'm writing it down. Maybe that's why. Okay, you're right. Go down, everybody. I didn't realize I was scrolled down. Maybe I just cleared it down. Okay. So, okay, I repeat. My question is, I have two end systems, A and B. I'm talking about a service of data link layer that is reliable delivery. Typically, whenever you discuss reliable delivery, TCP comes to your mind. TCP is a transport layer protocol. Then why am I talking about reliable delivery of link layer? The answer for this is that if I have if I have A sending datagram to B, I am now sending a packet here. Let's say this is my packet. Now, if this packet goes across all these, but somehow between these two devices, that is X and Y, the link here is faulty and the packet is not able to transmit, or link was busy, there was congestion and so on, packet could not reach to B. What happens in this case? B tells A, I have not received this packet with the help of this TCP, the higher layer protocol, and A sends it again. This is what is transport layer's reliability. But when we talk about the data links reliable delivery, we talk about correcting the error locally, in the sense that I have data link layer available here at X. I have the data link layer available at Y. So if I have these two, what I'm speaking about, if I can do retransmission of data from X and Y, because Y did not receive it, only X has the copy of it, it sends it back again to Y. I can get the error fixed locally here. So I don't need to retransmit from all together there. I can get it transmitted here only. I can save a lot of time. So B would receive it and B would not inform A to resend it in this case. So do everybody understands this difference of reliable delivery? So in short, I can write it down here for you to note down. Rather than forcing an end to end retransmission of the data by a transport layer protocol or application layer protocol, link layer corrects locally. This is what we have as reliable delivery. However, some books would also mention that it is an unnecessary overhead. For what is, yes, I will take it as unnecessary overhead, but not for all. For very, low or negligible error prone links like fiber, this is unnecessary overhead. We do not need to have this, protocol working if there are negligible errors. But for wireless transmission, which are bit error prone links, we require this. Keep that in mind. Unnecessary overhead, there are two cases. I'll just mark here. I'll say yes for low bit error links. I'll say no for high error prone links. That's why you would see, because of this reason, many wired link protocols do not provide reliable delivery service at the data link layer. Why overhead? Because there would be a protocol that would be working to check it. And that protocol, while checking, would take some time. If you do not have some errors, why to do this? Moving on to the next function. The next function is flow control. I'll draw a node here. And then I have a router here. And then I have another node here. They are connected via links. Let me have links here. This is A, B, this is R. I have two nodes here, A, B, and they are both connected to the router that is R. Now, when A starts to transmit packets, to R, likewise B also starts to transmit packets, both of them moving to R. Each node within our network, within the link, have a limited amount of buffering capacity. What is buffer? We have discussed this, wherein you queue in the packets, okay, wherein you put the packets together. Now the problem here is that as the receiving node receives the frame, if it only A was sending and its capacity of buffer is enough to take about A, it takes the packets of A, processes and then passes on, it is fine. Now when B also sends at a faster rate, A also sends at a faster rate, R may not have that much capability to process the packets of both the flows of A and B at the same time. So it is receiving more data, okay, within some duration of time, within say time interval, and it cannot process that much of data within that interval. Now what it does, it puts some within the queue, but again queue is limited. If flow is more, queue is full, what happens here? We have seen those here packets going as packet loss, packet drop. So in this case, frames can get lost because we have a buffer overflow. So link layer can provide flow control in order to prevent the sending node, that is A and B, to send data at this rate. Let me give an example to understand, right? I will say something and you will see whether you will understand this or not. Link layer is a reliable delivery that can be considered as a necessary overhead for low bit error rings in hyperconvergence. For this reason, many wide protocols do not provide a relevant. So, did you understand this? Anybody? No. Then what would you tell me, Ramanand?
Slow down, sir.
Exactly. Slow down. Good point. Slow down. Then I will say, okay, link layer reliable delivery can be considered as an unnecessary overhead for low bit error rings. Now it was fine. When I went fast, it was overflow like Ubaz is mentioning. Now somebody said slow down. Okay. And who said slow down? Right, Rahul. That is the exact term that you used is slow down. This is what R would tell A and B. They would say using a protocol, a link layer protocol, that I have to control the flow control. That don't overwhelm me by this rate. You're sending me these packets at a very fast rate. Don't overwhelm me. I would write this term here. Overwhelming. And what is overwhelming? This is what I did to you. I overwhelmed you with fast data transmission. So flow control in the data link layer helps us to prevent sending node on one side of the link from overwhelming the receiving node on the other side of the link. Slow down. Don't send me at this rate. This is what flow control is. Any question? Then I move to number 5. There are different protocols. We'll discuss these within each when we discuss. We are discussing the functions of each. Let's first finish the functions. Sorry, we're not taking each. We're just discussing the functions. Then we'll take each of them separately. Error detection. Yesterday, we discussed one of the points when we towards the end of the class in which we took the transmission impairments. What are transmission impairments? That is that when you send 0 from one end to another end, or you send 1 from one end to end, 1 may not be received as 1. Okay, 1 may change to 0 and 0 may change to 1. So a node receives the data incorrectly because 0 got changed to 1. They are known as bit errors. And why does bit error occur? Yesterday's class, because this is introduced by signal attenuation that we saw. Also we saw noise like electromagnetic noise, that is also there. So what do we have here? We have here an error detection mechanism provided by the data link layer, in which it can check. It would have a mechanism to detect if there is an error within the sent frame or not. It can detect whether there is a one bit error, or there are multiple bit errors, like we have burst errors. So one or more errors can be detected using error detection mechanism of the data link layer. How it is done? The transmitting node, in our case like we had A, it sets some error detection bit within the frame. Example of what information does the header of frame have, the header of data link layer have. It has information about what error detection mechanism am I using. How can you check whether it's CRC, whether it's something else? How can you check parity? How can you check if there is an error in the packet or not? Let's say you are using parity error checking. Is it even parity, odd parity? That information is kept within the frame of the header as well. So once the receiver receives it, it opens the header of the frame and sees it. It performs that error check, and then it sees whether it's okay or not. Error detection is typically implemented in the hardware, whether it's your switch or whether it's the sending node. And then what happens after error is being detected? We have number 6 function as error correction. Now what is error correction? It can detect, one is detection, fine. Once it is being detected, what to do? Correct it. So we have detection as well as correction done by the data link layer protocols, which means we have to find exactly where the error has occurred, which bit has been changed from 1 to 0. And then once it has been changed, you find out, okay, this is which was changed, correct these error as well. These are examples. And some books would also mention that half duplex and full duplex is covered by the data link layer as well. Yes, there are some protocols which help in half duplex and full duplex transmission as well. So you can have that also as example here. This is partly covered by the physical layer and partly covered by the data link layer. The next is the hardware that we see within it. These were the services or the functions. So the hardwares, the typical example that we have, if you go to the page I gave you, there is written few things. And the most important thing that we have is an adapter. And when we say data link layers are communicating with each other, we also rename or rephrase it, reterm it as adapters are communicating with each other. So adapter is the best example for the data link layer. And what is adapter? NIC. That is the network interface card. Let me just Google NIC, the network interface card. So we have a picture. Typically in the class, I used to get all these, devices with me to the class that you used to pass on around to see how it looks like for those who have not seen it. I used to bring a switch, a hub, Ramanand, what do you see? Okay. So you see this device here. This is what we call as network interface card. If I can have annotations here, yes, I can have. Within this, I will mark this part. This is the interface. The whole of it is network interface card. This is interface where we connect the RJ45 connector, which I showed previously, and from starts the link. This is the part which connects to the motherboard. Overall, this green part is the PCB, that is the printed circuit board. And what do you see on these things, these ICs and so on? There is a RAM in it, which may be somewhere here. There is DSP chip in it, signal processing. This interface, this side, this is known as the link interface, the one which I'm marking here. This side which connects to the CPU or the motherboard, this is known as host bus interface. Let me just type here. This side is host bus interface. This side is link interface. And what else we have inside it? We have RAM, we have chips for DSP, digital signal processing, and so on. This is what we know as the network interface card or NIC. Okay, now I'm back to the, so this is an example of the data link layer. An adapter is supposed to do all the functions that we just now discussed. Adapter is supposed to do framing. Adapter is the one who encapsulates the frame from one end and passes on then to the communication link. And this is where the physical layer would actually start sending this as ones and zeros. On the receiving side, again, we would have the same NIC, the network interface card. Am I audible? Okay. So on the other receiving end, receiver would also receive these through this adapter and pass it on. So if we have error detection, if we have reliable delivery, if we use MAC protocols like random access protocols, if we talk about framing all the functions, these all are done by adapter. That is an example here I showed NIC. Now you will see that, okay, my laptop doesn't have this adapter. Does that mean I don't have, but you are still connected? No, you would have a wireless interface for it. Your NIC network interface card, you would be having a wireless network interface cards somewhere within your laptop, a small chip. Some, desktops used to have a small antenna coming out. That is a wireless network interface card. A network interface card in a router would be there, which would look like typically having a fiber input as well. It would have RJ45 input as well. And what is this adapter? What is this NIC? This is a semi-autonomous unit. I'll just write it up. Semi-autonomous unit. What do you mean by semi-autonomous unit? Semi-autonomous unit is that it can do things by itself to some extent. It is not completely, control. It doesn't have control on itself by itself. Like for example, we say NIT, Srinagar is an autonomous issue. We have our own rules. We are all examination. We conduct. We are not dependent upon somebody who issues a calendar for us. Okay. Then we go to another, let's say another college, let's say SSM. It's a semi-autonomous unit. Why? Because it can take some exams by itself, sectionals and so on. But for the final exam, it has to be dependent upon Kashmir University. Here also, NIC is a semi-autonomous unit in which an adapter gets a frame. It determines if the frame has error or not. If there is an error, it discards the frame. In this case, data link layer does not have to ask anybody whether I should discard it or not. A data link layer does not inform the sending node that I am going to discard it. Okay, so it has this kind of autonomy by itself. Whereas in other case, it is semi in the sense that it is not wholly on its own. It is sharing some stuff with its complete node, like it would be placed in the same box as the node. It shares the power, it shares the buses with the rest of the node. So ultimately you would see that it is under the control of the node. And the components that we saw apart from these, DSP chips, RAM chips and so on, the two interfaces that you saw, one was the bus interface, another one was the link interface, which I showed you inside the picture. Bus is responsible for communicating with adapter's parent node. Let me just write it down. Bus interface. So bus interface is responsible for communicating with parent node. Those were the golden lines on the PCB that connects to the, let's say, PCI slot of your motherboard. The second is the link interface, and link interface is responsible for implementing link layer protocols like framing, deframing, error detection, random access, transmit, receive correctly, and so on. Okay, we have 11:31 already. Okay, any questions? I'll end the class today. Any questions? No? Okay, then we'll continue with our next class. We'll start in our next class the multiple access protocols. Fine. If you don't have any questions, yes, please go ahead, Ankur. You can use microphone also if it takes time for you to type. And if your, voice quality and their internet is fine, so you can use that as well. Another thing is regarding the,
Sir,
yes,
sir, what's the difference between transmission delay and store and forward delay?
store and forward delay is basically the delay that is within the router. What it has to do is I I am receiving a parcel and the parcel is so big that first I need to completely receive it, then I can transmit it. Okay. It's like a parcel that I am supposed to receive is of uh, 10 computers. When I receive the first computer, I am waiting for the rest of the 9 computers. Once I receive the rest of the 9, then I can go on and pass on the packet to the next node. This means first computer is my first bit and the last 9 is the remaining 9 bits. Until and unless I read 10 bits which forms one packet, I cannot pass it to the next node. This delay is known as store and forward delay to make sure that entire packet has been received by node. And this comes at the beginning. So I will draw a figure here. This is the router. Okay. I have the incoming link here. I have the outgoing link. Okay. So if I'm talking about the store and forward delay, I would have that delay somewhere here to ensure that packet is completely received. This is store and forward. Ankur, can you see it?
Yes, yes, sir.
The figure is there? Okay. Now you're talking about transmission delay. What is transmission delay basically? Link is transmitting some packet already. Now this packet is now available within the router. Router saw its destination and has decided that it is to be moved from this link to this link here. Because router can have many input and output links. Now it knows that this is the destination link where I have to send. But on this link, there is already some packet which is flowing. So it would have to wait here for some time till the link gets free. So that time in which the packet is transmitted onto the link from the node is transmission delay. After that, it will face on the link propagation. Do you get the difference here?
Yes, sir. Yes, sir.
So black one would be the transmission and the blue one would be the store and forward delay. And another term we will come to, next class, hopefully it would be cutthroat switching in which we'll minimize this store and forward delay. Any other questions? I hope you got the answer.
Yes, sir.
Any issue with Riverbird Modeler? I am having myself an issue because it's 600 MB. I have to download it before Friday. For 2G network, yes guys. What are you going to do with Riverbird Modeler? Arifa? For those What can you do? You can't. I mean, I can't help myself this time, but it fails. I understand. I mean, 600 MB over a 2G network. Try downloading during the night. Maybe speed is better. Compress and zip the clip. SCR can send it on WhatsApp. Because how much can it be zipped? Do you think 600 MB can be reduced to a small one? Okay. Yeah, would downloading these using accelerators and so on help? Maybe you can try using that. I don't know. Let's see till Friday what we can do in this and have a lab accordingly. But if you want me to delay the lab, if it cannot be downloaded, then okay. Vikas says that it can be downloaded greater than 75%. That would be good. Ramanan, can you give it? Okay, Vikas, can you try it and share it? Vikas will give this work to you. Good. Kindly do this and see whether then through WhatsApp or whether through Google sharing sites, whichever is easy, others can get this as well. Share it to me also because I am myself facing this problem. Where's the clip? It's not the clip, it's the software, it's the model that we are talking about. It's the software for this simulation. Okay, okay. Vikas will try. Let's see what Vikas can do for this. And Ramanan, upload these videos so that for those people who cannot download these videos, they can watch it on YouTube. They can stream it at a lower quality and so on. You can upload it at the best quality, then we can stream it at different qualities. Send me the link so that I can put it on the website as well, okay, including today's classes. All right, then you might have next class. So thank you so much for listening. I'll see you in the next class. Okay, bye-bye.